what I want you to see in this video is that we've been adding fractions for a while and you know how to do this, but I'm just going to formalize this for you so you can use it for your homework over the weekend. So in this example, 1/5 plus 2/5, I can think about this as if this is my whole, a whole number 1, and I'm going to separate this into fifths. And this 1/5 is here, and then I have 2 more fifths here. And I can now see that instead I have these 3 sections out of these 5 that are included. So I have 3/5. A nice, really good shortcut way for us to think about this. I mean, we could do a ton of these examples, but if you have, sorry, that's too faint. If you have something like 2/11 plus 6/11, I know that my 11ths are staying exactly the same. So like we divided this into 11 sections. So it's just saying now instead of having just 2 of those sections and 6 of those sections, I instead now I'm going to have 8 of those same 11 sections. So you can see really nicely that your denominator, 11, 11, 11, stayed exactly the same. And it was just the numerators, the numbers on top, that were being combined. What gets to be a little bit more interesting is that when now we have something with different denominators. So let's take 1/5 plus 3/10. So I'm going to take my fraction bar, again, this is a whole, and I'm going to call this fifths. And now I know that I already have 1/5, and I'm done with that. Now 3/10, you know that there are 2/10 and 1/5. So I'm going to just turn these into, instead, tenths. So now I have 3/10, 3 more tenths, I should say. So let me fill in 3 of those sections, 1, 2, 3. So now we have this part is here, is all taken care of. So you have 5/10 is going to be our sum, which you already know, of course, is a half also. But check this out. See what happened to the 1/5 here in this picture. Now this 1/5 actually became 2/10 when we turned all of this other part into tenths in order to put that 3/10 in. So another way for me to do this same problem is instead to say, what is 2/10 plus 3/10? And that gets us, just like we saw on the last screen, the denominators stay the same, and I combine the numerators, so I get 5/10, otherwise known as a half. So we could take anything we wanted. We could take 1/8 plus 2/3, and we could say our common denominator here, what they would both 8 and 3 go into, is 24. I really like to write my fractions when I add so that I can see what the new fraction is right next to it. It makes it easier for me to find the equivalent fraction. So what numbers do both 8 and 3 go into? So I could make a list if I wanted 8 and 3, and I have 3, 6, 9, 12, 15, 18, 21, 24, 27, etc. And the 8 is 8, 16, 24, and I can see right away that I have a 24 here and a 24 here. Or a lot of you, I think, would probably say on that problem that you could just tell that 8 and 3 both go into 24, which is fine. So here we go, 24, 24. 8, 3 times 8, so if I multiply that number, the denominator, by 8, I have to multiply the numerator. So I get 16/24, so that's my new fraction I'm going to use. And here I'm going to have 8 to 24, I'd have to multiply by 3. So 1 times 3 to keep it equivalent. So now my new problem is 3/24 plus 16/24. Again, denominators stay the same, which is awesome, and my numerators I just combine. So I have 19/24. Last one I want to show you is that if I had something like, let's see, 1/6 plus 2/3, that I have so many options for common denominators, and it doesn't matter what you pick. I recommend you pick the smallest one, so then you're dealing with smaller numbers in general that you're adding, but it does not matter. So just to prove that to you, I could say that I have a common denominator of 6. So I have 1/6 equals 1/6, so we don't have to do anything with that one. And I have 2/3 is how many 6? So here I have to multiply by 2. I have to multiply by 2. So I get 1/6 plus 4/6. So that is a total of 5/6. Again, denominators stay the same, numerators I combine. So I'm going to show that now over here instead and say 1/6 plus 2/3. And instead, I'm going to pick a denominator that's much bigger than I used on the other one, and we're going to see it works just as well, which is great. I'm going to say this time my denominator is 18, because 3 times 6 is 18. And I am going to say 3 goes into 18 times 6. So 2 times 6 is 12. Then I have 6 times 3 is 18. 1 times 3 is 3. When I combine those, I get 3/18, 12/18. Denominator stays the same. 3 plus 2 is 15. So then I would just ask you, what's the difference between 15/18 and 5/6? How different are they? And you know right away that those are actually equivalent fractions. 5/6 is equal to 15/18, because all we've done in both cases is multiply the numerator and the denominator by 3. So again, just have the same denominator, and then the denominators stay the same, and you just combine the numerators. See you Monday.